Hello, everybody. I'm Adrian Nixon from the Nixene Journal. I'm the editor, and today I'm talking again with Dr. Vivek Koncherry, who is a really smart researcher at the University of Manchester, and he's an impact fellow, and also been at the university for probably 20 years,
Yeah.
Vivek, something like that.
Yeah.
And you specialise in composites and materials science, and you invent things. And this time, you've been playing around with space stuff, haven't you?
Yeah.
And one of the world's biggest architectural firms as well. Can you tell us something about what you've been doing?
Oh yeah, I love to. Thanks, Adrian, for this invite. And I love to talk and spread the news about this new project we are working on. It's in partnership with a US-based company, Skidmore, Owings and Merrill.
And they're not just US, are they? They're global.
In fact, they're a global architectural firm with so many beautiful buildings around the world. Let me show you a couple of pictures of Skidmore's.
Yeah, do.
They designed. I mean, they designed the tallest building, Burj Khalifa, which is on the left in Dubai, and the other one on the right side is One World Trade Center in the US. So they have lots of experience with architecture and beautiful buildings. And in this project, they helped us with the design and engineering concept for the space habitat. And of course, very well in Manchester, we are really strong with material science and manufacturing. And with graphene, we have the Graphene Engineering Innovation Center. So we had a lot of backing from the GEEC as well, Graphene Engineering Innovation Center, for this development. And there are some cool images as well, which I can show it to you.
Yes, let's have a look. What have you been playing with?
It's the beautiful. I would like to credit one of the architects who led the design as well. His name is Daniel Innocente. He and his team were helping us with the designing of the structures. And Manchester team's contribution is in the materials and manufacturing side. I will also like to acknowledge a French company, Lexicon. They helped us with rendering these beautiful images. In this image, you can see the low Earth orbit habitat designed by the SOM. And on the left side is an Orion capsule. This is to shuttle people to the habitat and back. This habitat could be for space tourism or for science purpose. There are a lot of applications for this. And there is a beautiful picture of the observation deck as well, where people can go there for tourism or science and study the universe or asteroid systems. And we also have lots of satellites in low Earth orbit, so people, the maintenance teams and everything can be in this habitat. And this is some other picture with the heat shield closed, because if we have an observation deck, we need to protect the inside equipment from the solar radiations and stuff. So we can't keep the opening open all the time. So there are shield in here. The shield is closed. There's a picture of shield open. We can see around. This is another picture of the space habitat with Earth in the background and Orion capsule to shuttle people on the left side. This is something we are working on. I mean, within next few months, we already got a 3D print model and small samples of composite graphene structure to demonstrate what's possible. We made it last week, and we are now working. In fact, Skidmore, Daniel and me, we were talking on the manufacturing side. We want to make the scale model, which is a small, about 0.5 meter to a meter. We're still working on the exact dimension. We are going to make the small model in the next few months. So we have the best design. We have the new composite structure with graphene inside. It's ready to be, we can test it. The one thing I realized, we do a lot of projects at the coupon level in the UK. I mean, we are good in science, really good in science, but we want to push for the entire structures, the whole structure manufacturing, because especially in the north, we are very strong with material science and we are very strong with manufacturing, and we want to capitalize on our strength. So this is a good example of what we can do, and we do have the know-how and the material science knowledge. I mean, it still needs testings and validation, but we got something. We are at the early stages, I would say, still.
Yes, you talk about materials. Yeah. Now, spacecraft are normally made of sort of aerospace quality titanium, aluminium, that sort of thing, various alloys. So why graphene? What's special about what you're doing?
A very good question. I mean, International Space Stations is mostly made with metal. Yep. And metal works, there is no problem. But the problem is it's the weight. If you want to carry a kilogram of material from Earth to space, it costs several thousand pounds. It's not just the weight. Composite structures performs better. It's in this habitat, which I showed you earlier, it's not just composite structure. There are heat insulation materials. There are thermal shieldings. It's a multi-layer structure.
And these have graphene in them as well.
These have graphene. I mean, graphene is in the composite structure. It enhances mechanical performance. Yep. But the main case we are putting the graphene is for the thermal management. An example: if you take a single layer of graphene sheet, and if you touch on one end, the whole heat transfer to the other side. Yeah. An example, in space, we have a problem where it faces the sun. The habitat facing the sun is plus 127 degrees Celsius. That's and at the same time, it's a bit hot. It's a bit hotter than sauna. This is at the back side is minus 170.
Wow. So you've got over 200 degrees, nearly 300 degrees centigrade of difference.
Yeah,
between the sunshine and the shadow.
Exactly, and
every time it turns round, then that's dynamic as well. That's changing all the time.
It's changing constantly.
Whoa.
And we want to see if we can, with graphene, is one of the best conductors of heat.
Yep.
We can transfer heat from the sun-facing side to the cold side, so we can disperse the heat around the structure evenly. So otherwise, we need to have cooling system on one side and heating system on the other, and that also need energy. So we need heat dissipation, and graphene can play a major. I mean, graphene is one of the best materials. So there are other two-dimensional materials as well, which can play a major role in heat transfer. I mean,
like HBN perhaps.
Exactly, and few other materials as well. It's very good with heat transfer. Yeah, I mean, this technology is proven at least in small level in the graphene heat transfer capability. There is still some research needed. If you want to make a 12-meter long heat transfer, it's possible, but there is a research element in there as well. But the thing is that won't stop our structure development, because in the structure of carbon fiber, we know for sure. Carbon fiber composites a proven material on Earth. An example, in the A380 aircraft or 787 MAX and these new aircrafts, it's all made with carbon fiber, and it's running for decades and no problem. Yeah. People talk about regoliths and printing regolith. It's a good idea to print structures in Moon or Mars, but it's a long way away because even on Earth, it's still a difficult thing to do. And especially in high performance conditions, it's not tested. So long term, that's a solution. But at the near future, it's better to make in Earth and carry it to the space.
And so these carbon fiber composites can be enhanced with graphene, and that's what you're working on.
Yeah.
And they can improve the strength, they improve the thermal conductivity, so you don't get heat problems.
Yeah.
They'll probably improve the fatigue resistance as well, because they're handling temperature better.
Yeah.
And also, it seemed to me, just looking at those rendered images, they're beautiful, by the way. Your partners have done a fabulous job.
Yeah.
Are they about the same size as sort of aircraft manufacturing at the minute? So
good point. I mean, if you look at the design, designs I showed you earlier, like a cone-shaped structure, is very close to a fuselage of an aircraft. And there are already robots available that can design the fuselage kind of structure. And in fact, this could be even a bit smaller than an A380 aircraft. So there are robots which can make that composite shape much larger than what I showed you. So which means we do have the material know-how. We do know the manufacturing. So we just want to make, we need more partners to put an actual space, the habitat in space. I think that is what we should push for on habitat. I mean, some scientists want to mix graphene and other materials in graphene in the space, because there is no gravity, so you don't have the problem of settling down and things like that. So there could be many interesting science experiments which could be done in a very low gravity environment, where you don't have to worry about the material settling down and things like that. Yeah.
So you can make these elements of a space station on Earth using standard aerospace technology at the moment, enhancing that with graphene so that can be transferred from just the aero bit up to the space bit. And you're dynamically working with some of the top companies in the world at the moment, designing these things. Amazing. And you're looking for partners to work with as well in the space sector.
Exactly. I mean, Skidmore, they did a fantastic job with the design and the structure, and Lexicon did a good rendering. Now we can tell the story to the people with both these partners. The whole world can see what we are doing. There is still testings need to be done, and validation is need to be there. To be honest, I'm not concerned too much about that, because composite structures are well proven in aerospace and automotive, but we still need some testing element to it.
So if Elon Musk or Jeff Bezos or Richard Branson are watching, then get in touch with Vivek, because he's doing some really cool stuff that can help you get your stuff up there.
And we will do with graphene the best, the advanced materials. And to be honest, I don't think any large corporation have the know-how of graphene material, like Graphene Engineering Innovation Center. That much know-how in graphene, I don't think any corporation other than Manchester have that,
So you can unlock a lot of materials solutions for these space guys.
Exactly. And high value manufacturing as well for Manchester and, for the UK and globally, to be honest. It's for science. We need to have this.
Fascinating, Vivek. We're going to have to stop there, because I could talk to you all day. But again, Dr. Vivek Koncherry, thank you very much for your time. And best wishes and good luck for your future in space.
Thanks.